So good afternoon, one and all. It's estimation of feeding, estimation of feed in the hypothesis. In this basic concepts of estimation, this of good estimator, consistency, unbiased, and efficiency. So in this basic terminology, estimation of feed, good estimator, what we have to take here. A random sample we are taking it x1, x2, xn, so on, xn of size of n was drawn as a known probability distribution probability function consisting of a parameter. What's the parameters of the x1, x2, xn? For example, a random sample size drawn gamma population, the probability that we will get f of x is equal to a power lambda by gamma of lambda e power minus ax x lambda minus 1 by 0 lambda is 0 less than x greater than where lambda and a are population parameters, usually they are unknown. Then these parameters are estimated using theory of estimation. The theory of estimation was introduced by Professor R. Fisher. When it is decided to estimate these parameters, there will be an infinite number of functions of sample values known as statistics of which may be used as estimates of population parameters. We shall discuss how to estimate these population parameters and the criteria for the good estimator. The objective is not only estimate the population parameters, determine the best estimate. It falls nearest the values of the parameter being estimated. Suppose theta x1, x2, xn, theta 2, x2, x2, xn we are taking here. Theta to x2, xn. So theta to x1, x2, xn are the functions of the sample values referred as estimated available to the estimate of population parameters. Now an estimator is said to be the best, which is the distribution as closely here or equal to the true of the parameter theta x1, x2, xn, that is I1, 2. The basic terminology of estimation. What is this basic terminology? The statistical constant which is obtained from population data is known as parameter. Usually they are known. Example, population average mu, population variance sigma square. Means average means the total, the variance is distinct. Population regression coefficient beta is the parameter. Statistic. The statistical constant which we obtain from the sample data is known as statistic. Sample average x bar and sample variance is x square for statistic. Estimating of functions like theta 1, x1, x2, xn. X1, x2, xn, which are the usual estimated parameters, are referred as estimators. Properties of good estimator. An estimator is said to be a good estimator if it is the following characteristics. One is consistency. Consistency, unbiasedness, efficiency, and sufficiency. Consistency, unbiasedness, efficiency, sufficiency. What's the constants? The term consist estimator of is short. The per consistent sequence of estimators The basic idea of consistency is that the repeat estimate of result again and again, steadily increasing the sample size, eventually assuming that the estimate is constant, the sequence will converge on the true population parameter. This convergence is called as a limit point. Theta n will be a good estimator is the difference between the theta small theta modulus of theta n minus theta is a small possible value we are taking here. But theta n is a random variable. What the random variable means is that we are taking the random variable means not ascending and descending, we are taking the random. It's a middle or lost or infinite value. We think that the own sampling distribution of the range may be infinitely large. Therefore, the sampling distribution of theta n becomes own sampling distribution, range may be infinite. Therefore, the sampling distribution whose range may be infinitely large. Therefore, the sampling distribution of theta n becomes more and more concentrated around the parameter as the sample size increases here. So therefore, what is the size of unless the degree of the connection increases within them, there is a no pointing that there is a theta p, not theta cap. What is the theta cap here? The theta cap here, what is the value we are taking here? Modulus of theta cap n. Just a minute, stay on the line. So, for any again epsilon greater than 0 should be an increasing function n. So, therefore, we are taking here each theta p, theta n, we are taking theta p, theta n, we are taking here. Theta p, theta n, we are taking here the theta n less than 3 for any given here, we are taking here.
So, hello. Okay. So therefore, we are taking here. So therefore, so see here, the consistency here, the term consistency here, the term consistency here. So the term consistency here, the estimator of the small short of the consistent of estimator. The basic idea of the consistency estimator again that here. So the basic estimator of the consistency here we are taking here modulus of theta n minus theta. So modulus of theta n minus theta. So modulus of theta n modulus of theta n modulus of theta n modulus of theta n minus theta. Sir, 1 minute. So modulus of the we are taking here, we are modulus of the taking here. So modulus of the data, what we have taking here, modulus of the data taking here. So therefore, the modulus of theta n minus modulus of the theta n minus theta, the theta 1, theta 2, theta 3, theta 4, theta 1, theta 2, theta 3, theta 4, that is less than 0 we are taking here. So therefore, that is a value. That is a value we are taking. That is a value we are taking here. So what is that value? What is that value we are taking that area? So therefore, we can just a minute. Just stay on the line, please. చెప్పు నేనే ఉన్నా ఇక్కడ కూర్చున్నా అవుతుందా లింక్ అవుతుందా షేర్ అవుతుందా స్క్రీన్ షేర్ అవుతుందా లాగిన్ అవ్వండి గ్రూప్ లో షేర్ చేయాలి మరి ఇక్కడ బుక్ ఉందా మరి జూమ్ లో ఎట్లా పెట్టుకోవాలి నేను ఫోన్స్ ఎట్లా పెట్టుకోవాలి మీ క్లాస్ అయిపోయిందా కంప్యూటర్ కంప్యూటర్ చెప్పాలి కూర్చోండి నేను ఆన్లైన్ డిస్టర్బ్ చేయదు అయిపోయిందా కానీ
Sir, you're not audible.
Now audible? Now audible?
No, you're yes, sir. Yes, sir.
Unbiased estimator is x is equal to x1, x2, xn is based on the distribution having parameter value theta and theta n x1, x2, xn is negatively based estimator. అంటే ఈక్వల్ టు 0 మైనస్ theta జరిగినప్పుడు any other estimator is not unbiased. అంటే unbiased estimator ఎప్పుడు అవుతుంది? b theta is equal to e of theta n x1, x2, xn minus theta అయినప్పుడు b theta is equal to 0 అంటే ఈక్వల్ టు 0 అయినప్పుడు మాత్రమే the value of the parameter theta cap n x1, x2, n is called as unbiased estimator. Ante equal to 0 ganappudu that is a not unbiased called not unbiased, then it is called biased estimator. That is not equal to 0 we can call as biased estimator, then equal to 0 we could call as biased estimator, unbiased estimator. So therefore xi equivalent to n mu sigma square, then show that the example x bar is equal to x1, x2 plus 1 xn by n is an unbiased estimator of mu. Given that x bar n mu sigma square e of x mu e of x is equal to sigma, that is normally we are writing e of x bar is equal to x1 plus x2 plus xn by n. So 1 by is variance we are writing in the bracket 1 by n within the brackets variance. How we can write the variance e of x1 plus e of x2 plus e of x3? So that e of x means small n into mu by n. But in the numerator and the denominator n is cancelled, it should be mu. Xi n mu sigma square, then show that the variance s square 1 by n minus 1 sigma x square is on the unbiased estimator of the population of variance as x square. You have to study this problem. This is the remark. Now I am going to the efficiency. You have to write all the definitions, so unbiasedness and efficiency. Then the short questions. Let a random variable x follow. This is a very important. Unbiasedness, estimator, efficiency. These are the small questions. Let a random x be normal distribution with a mu and sigma square. Again, x equivalent to n mu sigma square. We know that the sample mean x bar is equal. What is the sample mean? Tell me what is the sample mean formula? Summation of. What is the sample mean formula?
Xi by n.
Xi by n means what is xi? Xi means x1, x2, x3, and so on. Xn is unbiased consistent of population of mu. In general, you have to write this definition. What they are asked to write the definition of efficiency means you have to write this condition x bar is called summation of x by n. When the x equivalent to n mu sigma square, then the sample mean consistent unbiased estimator, population mean mu. In general, that does not mean that the consistent of estimator of population parameters such as population mean mu. From this, it can be understood should be criterion. Choose one among them. Criterion which can be the various sampling distribution of unbiased estimator is known as efficiency. Then one definition here: if there is k is constant estimator by I is 1 to k of the population parameter. So therefore, if vi less than vi is all j not equal to n. The relative effectively is defined the ratio, the variance of the most efficient estimator to the variance to any other estimator. For example, two consistent estimated sample x bar and sample median m for population mean mu. So v x bar is equal to sigma square by n. So v m means what the problem in the definition they have given here. If 1.57 is a normal value, 1.57 sigma square by n for large n. For large n is 1.57. 157 is the formula. Since v x bar less than vm is the, hence it is concluded that the sample mean x bar is identified the population mean. So e v of x bar by vm. What's the formula? E means not I am asking e of x, only I am asking e. V of x bar by vm. So sigma square by n 1.57 sigma square by n, that is 0.639. This is called as efficiency. One example here, a random sample. What's the meaning of random sample? Tell me. What's the random sample? Nandi, random sample. Hello, I am audible?
Yes, sir.
What is random sample? Random
sample is when we
random sampling అంటే అడ్డదిడ్డంగా తీసుకోవడం అంతేనా?
Yes, sir.
మరి అది చెప్పడానికి ఎంత ఇబ్బంది పడుతున్నారు? Random sample x1, x2, n is size of 8 granules in normal population with unknown variance sigma square. The following estimate of mu here. See here very particularly theta 1 x1 plus x2 plus x8 by 8. We are taking theta to 8 by 87. This is the formula. మీరు ఎక్కడి నుంచి వచ్చారో ఎక్కడో ఇయ్యలేదు అనుకోద్ది. దిస్ ఇస్ ద ఫార్ములా. ఒకటి కనుక్కోవడానికి x1 plus x2 plus and so on xn by 8/8. Theta 2 8/87 by 1/4 x1 plus x3 4x2 6x1 plus 3/8 x 3/8 x4. Theta 3 that is cap 2x1 plus x2 5x6 lambda xy4. These are for a problem. Not so these are problem. Now telling all these are problem. ఈ ప్రాబ్లం లో x1 x2 కనుక ఇచ్చినట్లయితే ఈ వాల్యూస్ కి ప్రాబ్లం అడుగుతున్నాడు వాడు. చూడండి, ఆ θ1 and θ2 is unbiased estimator of mu. Find lambda is such that theta is unbiased estimator. Find the most efficient estimator among them. ఆ రూమ్ ఖాళీ అయిందా చూడండి.
అయింది సార్.
ఆయన వెళ్ళిపోయాడా?
సార్
దయాకర్ని అడగండి మరి, ఆ రూమ్ కావాలని అడగండి మరి. Given that xi equivalent to n mu minus sigma square exi equal to mu vxi is equal to sigma square. xi is equal to 0, I naught equal to j is equal to 1 to 8. E theta j cap, he already told x1 plus x2 plus and so on xi by 8. So E 1/8 summation of y is equal to 1 xi. Anyway, తీసుకున్నాం కాబట్టి 1/8 summation of y is equal to 1 to 8. Exi 1/8 8 mu is equal to 8 cancel is equal to mu. E theta 2 cube E 8/87 1/4 x1 plus x5 plus 4x2 plus 6 అది ఫార్ములా రాసాం మీది, అవునా? సో 8/27 కామన్ తీస్తే 1/4 x1 plus x5 4e x2 ఎక్కడి నుంచి తీసాము? x ని ఏమంటున్నాము, x2 ని ఏమంటున్నాము, 4e x2 అంటున్నాము, x7 అంటున్నాము, 6e x7 అంటున్నాము. అంటే అన్నిటికీ వేరియన్స్ కలుపుతున్నాం, అవునా? అన్నిటికీ వేరియన్స్ కలుపుతున్నాం, అవునా అమ్మాయిలు? అప్పుడు అన్నిటికీ వేరియన్స్ కలిపితే 8/27 1/4 2 mu, that is 1/4 x1 plus x5. అంటే మ్యూ రాకుండా 0 అయితే దట్ ఈస్ బయాస్డ్ ఎస్టిమేటర్. అన్ని క్యాన్సిల్ అయ్యి మ్యూ ఉన్నట్లయితే దట్ ఈస్ అన్బయాస్డ్ ఎస్టిమేటర్ ఆఫ్ మ్యూ. ద సెకండ్ బిట్ ఇన్ దిస్ వన్, be given that theta cap is unbiased estimator. So E theta 3 cap is equal to mu. Theta 3 cap E 2 x1 plus x2 plus 5x6 plus lambda x5 by 4 is equal to mu. That is 1/4 2e x1 ex2 5x6 lambda e x5 is equal to mu. That is, we can write here 1/4 2e x1. e x1 అంటే 2 mu, e x2 అంటే mu, 5 అంటే 5 mu, lambda అంటే mu. అంటే e x ని ఏం కండిషన్ తీసుకుంటాం మనం? సగటు తీసుకుంటాం mu అని, అవునా? సో టోటల్ ఎంత చెప్పండి నాకు, అది మొత్తం ఎంత చెప్పండి? 5 2 3 5 10 mu 10 lambda mu, అవునా అమ్మా? 10 lambda mu ఏనా అమ్మాయి? లాంబ్డా వాల్యూ కనుక్కొని చెప్పండి రఫ్ లో ఫాస్ట్. 10 lambda mu by 4 is equal to mu. ఎంత వస్తుంది ఆన్సర్? lambda is equal to -4 is correct or not? Check with your rough notes. Make fast. త్వరగా. ఎంత వచ్చింది?
ఒక నిమిషం సార్ చేస్తున్నా.
త్వరగా. ఎంత వచ్చిందండి
సార్ ఇక్కడ
10
సార్
mu లేదు కదా సార్
అమ్మా
10 mu లాంబ్డా కాదు కదా సార్
రాదు
8
లాంబ్డా ఇస్ కూడా -4 వస్తుంది ఇంటికి పోయినాక చేయండి టైం వేస్ట్ చేయకుండా అవసరం వేరియన్స్ ఆఫ్ θ1 cap v is equal to x1 plus x2 plus x1 8 this is also we are substituting 64/79 you have to do it so this is the problem for unbiased estimator here this is another example of 1.3.8 also చూసారా ఒక్కొక్కటి 3-4 pages ఉంది చూసారా
yes sir
you have to practice any doubts ask me I will clarify okay మీరు క్లాస్ మొదట్లో వినలేదు కాబట్టి this is a very important question unbiased estimator constant estimator efficient estimator definitions అడుగుతారు definitions అంటే you have to write these definitions 1.6 let x be a random variable with the efficiency f of x comma theta then any statistics of the mathematical expression equal to the parameter చూడండి e of theta n for every n is equal to 1 to n when theta n set to be unbiased for theta e theta n not equal to theta n is the say biased estimated theta అంటే not equal to theta అయితే biased equal to 0 అయితే unbiased అర్థమైందా ఇప్పుడు మిమ్మల్ని
yes sir
theta is said to be positively based estimator of theta e theta n less than theta అయితే theta n is said to be negatively based estimator of theta a sequence of estimator kept theta n constant if and only convergence in probability just a minute So how we can find the good estimator here? So therefore, compute sufficient estimator of the population of the parameter. Understand the Fisher-Neyman factorization. There are very much important theorem is Fisherman factorization theorem. So compute the minimum variance unbiased estimator of the population median. So what is the sufficiency? I already told in the first unit. Efficiency, sufficiency, I already told in the first unit. Let x comma t is a family density function. Theta is known as parameter. Random sampling taken from f of x comma theta. Statistical inference. What is the meaning of statistical inference? Statistical inference means f of x comma theta. What is the f of x comma theta? What is the value we are using here? So therefore, it's a statistical inference, but the parameter theta. T is the statistics functions. T is the statistic. Statistics means in the design of experiments. In the 5th semester, you all learn. In the 5th semester, hello. In the 5th semester, you learn the design of experiment. F statistics, F ratio. F statistics means first two values తీసుకున్నాం. n minus m by some h అన్నాము, n minus m by k అన్నాము, ఇంకేదో అన్నాం. సో అట్లనే ఆ స్టాటిస్టిక్స్ వాల్యూని ఇక్కడ తీసుకుంటే theta is sufficient statistics అంటున్నాం. F is statistics of the ratio. So an estimate is said to be sufficient of the parameter. It is contained in all the form in the sampling population parameter. So t is equal to theta x1, x2, xn. So x1, x2, x3, x4, x5 అంటే ఎన్ని వాల్యూస్ తీసుకుంటామో మనకు తెలియదు. సో x1 to xn తీసుకున్నట్లయితే the estimate of the parameter is basically sample on x1, x2, xn is the form of the population. The probability density function we are taking. The probability density function we are taking here. So therefore we are taking the probability density function. What we are doing here? Just a minute. So in mathematical definition of sufficiency in mathematics. So page number, this is 23. So mathematical definition of sufficiency. Suppose that x1, x2, xn. F of x theta sufficient of theta is the conditional distribution x1, x2, t does not depend upon theta. Phi of x1, x2, xn is equal to phi of x1, x2, xn into t. అక్కడ by comma t theta అన్నాం. ఇక్కడ t అన్నాం. అంటే sufficiency లో మనం it is a dependent variable. Sufficiency it is a dependent variable. So that's why we are writing here phi is equal to x1, x2 and so on xn by t. Very most important theorem, that is a Fisherman factorization theorem. So what is the Fisherman factorization theorem? See here. Let of a random sample size f of x theta whose range is independent of x1, x2, xn. The necessary and sufficient condition here, the f of x minus theta admits a sufficient is that the probability distribution function, the PDF, you know that the PDF probability distribution function, that is phi of x1, x2, xn splits that the product of the two non-negative functions and we have theta w is equal to x1, x2, n is the independent the sufficient conditions here. So what is the sufficient conditions here? What have you phi of x1, x2, xn? Phi of x1, x2, xn ఏమని రాస్తున్నాం అంటే మనం phi of i is equal to 1 to n f of xi theta. The Fisher Neyman factorization theorem లో phi of x1, x2, xn t, phi of x1, x2, xn ని మనము phi of మామూలు phi is equal to 1 xi theta. That is may be written as vi x1, x2, xn into w into x1, x2, xn. We can write in this one here. Where v of t or t x and wx is non-negative function, the function wx depends on the computed random variable x, but it not the parameter theta, the function t of x depends on, but we depend on random sample only through the value of t x1, xn. Then sufficient. What is the sufficient condition here? So what's the terms? It is given that phi of x1, x2, xn, the formula of x1, x2, xn into w x2, xn, where w is the independent, but v is the dependent. But v is the dependent. V is the dependent. W is the independent. So rewrite the equation here: phi of x1, x2, xn. That v naught is equal to into x1, x2, xn into u into x1, xn by t. So this is the p of t dash by t is independent of t. Very much important. This is t sufficient estimator for here. ఎందుకు sufficient అయింది? ఎందుకు sufficient అయిందంటే ఇది p అనే దాని డిపెండెంట్ వేరియబుల్స్ and conditions satisfy అవుతూ v0 t x1, x2, xn into u into u of x1, x2, xn ఈ రెండు కండిషన్ v0 లో t కండిషన్ ని u లో x1, x2, xn t కండిషన్ ని రెండు కండిషన్ సాటిస్ఫై చేస్తూ కండిషనల్ డిస్ట్రిబ్యూషన్ లో phi of x1, x2, xn by t కండిషన్ సాటిస్ఫై అవుతుంది కాబట్టి p of t dash by t అంటే t కి ఫస్ట్ డిఫరెన్షియేషన్ కాబట్టి దట్ ఇండిపెండెంట్ అవుతుందా కదా t dash by t అన్నప్పుడు ఇండిపెండెంట్ అవుతుంది కాబట్టి so therefore t is sufficient estimator of for theta. So therefore necessary condition it is given that t is sufficient estimator for theta. Let t y2 y1 y2 y3 అక్కడ y1 వలేదు y1 y2 y3 and the transmission of the random variables x1 x2 respectively. Let g y2 y3 and yn the pdf x1 x2 xn g y2 y3 yn So there are the joint PDF x1, x2, xn. So what is the joint PDF? So what the j is equal to new variables by old variables with the partial differentiation. With the partial differentiation. So the new variables by the old. So dou t by dou x1, dou t by dou x2, dou t by dou x1, dou y2 by dou x1. dou y అంటే dou t ఫస్ట్ తర్వాత dou y2 dou y అంటే ఫస్ట్ t ఫంక్షన్ తీసుకుంటాం. t ఫంక్షన్ ఎందుకు తీసుకున్నాము? The sufficient estimate. It is a sufficient estimate. Then y function. Then a y function y2 and so on up to go to the nth function we are taken here. So we can take in this is the marginal density function. The sufficient t is given by b of t theta, b theta t of x1 x2 xn. That integration of g t of y2 y3 yn dy1 dy2 dn. So L is equal to y1 y2 yn t of t y2 y3 yn t of y1 అవసరం లేదు. y1 అవసరం లేదు. Why? Because it is estimator. T is sufficient of estimator తీసుకుంటున్నాం కాబట్టి by y2 we are directly writing here. T of t to y2 y3 yn here b theta into L y. ఇక్కడ రాసాడు into L into y1 y2 రాసాడు. So y1 y2 yn by theta. Since t is sufficient estimator of t, the conditional density of y2 y3 yn independent of theta, hence the function is x1 x2 n. So the equation 2 becomes t y2 y2 y3 yn. So therefore equally monetary about this is called as Fisher-Neyman theorem. You have to study. Any doubts I will clarify in this regard. It is much more important for your 6th semester. Let x1 x2 xn, one example, let x1 x2 random sample drawn from the Poisson population with the parameter of lambda. Find summation sufficient estimate for lambda. Given that x equivalent to p lambda, the joint PDF is given by
speaker lock leva bettu speaker off cheyini enduku off cheyini speaker off cheyini mute lo unda mute
let x1 x2 xn be a random sample all from the Poisson population with parameter sufficient estimator for lambda. Given that x equivalent to p lambda, the joint PDF is given by the joint PDF is pi of x1 x2 xn. That is pi is equal to pi I is equal to 1 to n e power minus lambda by lambda x power I x power. అంటే ఇక్కడ ఏం చేస్తున్నాము? మనం ఏం వాడుతున్నాము? pi of I is equal to 1 e power minus lambda x power I by xi factorial. This is called Fisher-Neyman theorem. In this Fisher-Neyman theorem, that is expanding. I am expanding in the here e power minus lambda x power 1, e power minus lambda x power 2, e power minus lambda x power 3. That is x1 factorial, x2 factorial, and x3 factorial. That is equal to e of n lambda e power xi. Pi of I is equal to 1 to n xi factorial. E minus n lambda summation of xi to 1 by pi I is equal to 1 to n xi. So that is summation of xi lambda. It is a sufficient estimator of the Poisson. అంటే ఏం చేయట్లేదు, మనం ఎక్స్పాండ్ చేసి రాస్తున్నాం అంతే. Example, Fisher-Neyman theorem. We are asked Fisher-Neyman theorem. Let example, second examples also you can see here. I am going to all the topics. Complete sufficient statistics. What is statistics? A sufficient statistic whose sampling distribution is complete. A family density f of xi theta is said to be complete in the random variable x whose expectation is 0 for all 0 belongs to. What is the symbol? 0 belongs to omega. 0 belongs to omega, identically equal to 0. In other words, completely you are taking here, then f of x2 theta is a complete here. Family density wx అంటే RV అంటే random variables. మనం ఏమీ చేయట్లేదు. ఆ కంప్లీట్ సైంటిఫిక్ స్టాటిస్టిక్స్ లో wx is equal to 0 అనేది కనుక అయినట్లయితే అది say that f of x is equal to 0, that is complete random variable. Example, show that the binomial family density is complete. Very important. Show that the binomial family density is completed. So consider here, consider the binomial density function PR is equal to NR pi power R 1 minus I. Pi NR means NCR. NR means NCR. Let WR is a function, that is a function distribution with that WR is equal to 0. So summation of R is equal to 0 to N WR NCR pi power R 1 minus pi N minus N. The design in the correlation of చెప్పినట్టు 5th semester లోనే మనం ఒక ఫంక్షన్ ని WR ని తీసుకొని మళ్ళీ NCR WR కాన్స్టెంట్ ని పక్కన పెట్టి NCR తో pi పవర్ R 1 minus R తో మనం చేస్తున్నాం. సో 1 minus pi ని ముందుకు తీసుకొచ్చి summation of I is equal to 0 to N WR NR pi 1 minus pi whole power R. So summation of R is equal to 0 to N, that is called BNR NCR x power R. So these conditions are applying here. So these conditions are applying in this theorem. Please WRX is equal to 1 by pi 1 minus I and 1 minus pi whole power N not equal to 0. So EWR is equal to 0. What is the EWR? So EWR is equal to 0 aitene Fisherman theorem satisfy avutundi. So therefore, the binomial family density ECs are complete when EWR is equal to 0. That is where EWR is equal to 0. When WR is equal to 0, then binomial family R densities are complete. So another 2 point, show that the experimental family density is also complete. You have to study. Then what is the minimum variance? Tell me. What is the minimum variance? 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 And unbiased estimator. Minimum variance of unbiased estimator. See here, in a class of consistence of estimators, there is more than one biased estimator of a parameter. Then the interest is including the most efficient estimator of the waste and most efficient estimator. Rao-Kramers inequality, Rao-Blackwell-Stone. These two are very most important in Rao-Kramers and Rao-Blackwell-Stone. This is the minimum variance unbiased estimator. I am asked the definitions. Ask me. Yes. MVUE. So definition. If F is a statistic, T is equal to x1, x2, N is a sample size, then such that T is unbiased. It is a loss variance cross along unbiased estimator of theta. Biased ఎప్పుడు కాదు గుర్తుపెట్టుకోండి. It's not ఎప్పుడు కూడా bias జరగదు. ఎందుకంటే we are not giving the values. We are giving the equation part. It's not equal to 0 is impossible here. So therefore completely it is unbiased estimator. ఎప్పుడు కూడా biased estimator కాదు. కానీ why we are telling the biased estimator here, if any such things we are applying pi is equal to I is equal to 1 something, pi is equal to 0 we are applying. So then time we don't know whether applying the soluting whether the biased estimator is come or no. So that's why I'm telling the not equal to 0 and equal to 0 the biased estimators here. So that the variance is the among the cross of the all unbiased theta. The statistics T is called minimum variance unbiased estimator of theta. What is unbiased estimator? And MVU estimator is unique in the that Tn T1 MVU estimated theta. So T0 is equal to T1 almost everywhere. You have to study this 2.4.1 theorem. Any doubts I will clarify the class tomorrow. Each problem 2 to 3 pages. You have to study and practice. Don't need it, then only you good. Any doubts? Ask me for this class. I will clarify. Any doubts you can ask in the first unit. You have to doubts. Clarify your doubts. I will clarify your doubts. Fisher-Neyman theorem is very most important. Fisher-Neyman theorem and problem. Any doubts you can check your class works and ask me. Ask me in the problem. I will clarify. See the first and second units. I will clarify within 5 to 10 minutes. Make fast. you have to study first and second units and the MV also. Now I am going to this one. Student, define page number you have to see 35. Define the concept of sufficiency. State Fisher factor name and refactorization theorem. It's a clear only statement proof proof in the book. So see here, so what is a sufficient estimator? You have to write. I will ask. Define sufficient estimator. Define sufficient estimator. Define sufficient estimator. You have to write. What is your write? An estimator T is said to be sufficient parameter of theta. If theta is contingent of the theta is sampling pertinent to the population parameter, then the theta is for theta x1, x2, xn is an estimate of the parameter based on the example x1, x2, n is the size of the population with the probability density function f of x comma theta, such as the conditional distribution and other. And ఏం చెప్పట్లే అక్కడ ఇదంతా రాయాల్సిన పనిలా ఎక్కడైతే సఫిషియెంట్ theta x1, x2, xn అనేది ఎస్టిమేట్ ఆఫ్ ద పారామీటర్ అవుతుందో x1, x2, xn పాపులేషన్ ప్రాబబిలిటీ ఫంక్షన్ కి కండిషనల్ డిస్ట్రిబ్యూషన్ ఫంక్షన్ సాటిస్ఫై అవుతుందో అప్పుడు అది మనము సఫిషియెంట్ ఎస్టిమేటర్ అంటున్నాం. అవునా కదా? మిమ్మల్ని మనము మనం కండిషన్ డిస్ట్రిబ్యూషన్ కి estimated is sufficient for that parameter lambda constant all the information sampling pertinent to the population parameter theta is equal to see the year theta is equal to x1, x2, xn theta is equal to x1, x2 అనే కండిషన్ కి మనం ఫంక్షన్ f of x is theta కండిషనల్ డిస్ట్రిబ్యూషన్ స్టాటిస్టిక్ లో తీసుకున్నట్లయితే ఆ కండిషన్ డిస్ట్రిబ్యూషన్ కండిషన్ సాటిస్ఫై అవుతుంది కాబట్టి T అనేది సఫిషియెంట్ ఎస్టిమేటర్ ఆఫ్ T అవుతుంది. ఎప్పుడు అనేది మళ్ళీ చెప్తున్నా x1, x2, xn కి మీరు ఇదంతా రాయించినా రాయకపోయినా T is equal to x1, x2, xn అని కండిషనల్ డిస్ట్రిబ్యూషన్ ఫంక్షన్ సాటిస్ఫై అయితేనే అది సఫిషియెంట్ ఎస్టిమేటర్ అవుతుంది, లేకపోతే కాదు. దట్ ఈస్ ద మేజర్ ఫిషర్ నేమాన్ ఫ్యాక్టరైజేషన్ థియరం జస్ట్ నౌ I told. So you have to practice with the Fisher factorization theorem. Okay? Inka doubts? So first and second units almost covered in 1 hour.